In lesson 4.7, we're going to continue to talk about our congruent triangles. And just as a short review, at the top of the page, you can see I have listed all of the shortcuts that we have talked about thus far for proving our triangles congruent. We had side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. We also had discussed the fact that side, side, angle, and angle, angle, angle are not going to be shortcuts to prove our triangles congruent. That's not quite enough information to determine that two triangles would be the same. Well, in lesson 4.7 today, we are going to talk about specific parts of our triangle, the sides or the angles, and we're going to learn an acronym today. That acronym is going to be CPCTC. What it stands for is that the corresponding parts of congruent triangles are congruent. We had discussed this in lesson 4, that if our figures are congruent, the corresponding pieces or parts would have to be equal, and that's what this acronym says. CPCTC, corresponding parts of congruent triangles are congruent. CPCTC ends up being one of our justifications that we will use in our proofs. But before we can use it in our proof, we need to first prove congruent triangles. So let's take a look at how this works. If you look at the proof down below, it looks similar to what we had done before, but you'll notice that our proof statement is a little bit different. This time, I'm trying to prove that my segment PQ is congruent to segment PS. So as I come over here and look, my segment PQ congruent to my segment PS. Well, in this particular diagram, I do see that I have two triangles. And if I knew my two triangles were the same or congruent, I would know that those two side lengths would be the same. And so therein lies my strategy. I'm going to first see if I can prove congruent triangles. Then I'm going to go ahead and say that those segments would be the same. So we're going to take a little bit of a shortcut here. We know that we would always start with our given information, so we're just going to draw our arrow down there. Now this time, my given information, it says that PR bisects angle QPS and angle QRS. What I want you to know here is my segment PR is bisecting the angles. Not necessarily meaning I have congruent sides, but if this is bisecting angle QPS, that means it's cutting it right down the middle. And so these two parts of my angle are going to have to be congruent. Now if I make that marking, I'm going to have to go ahead and come over here and make that statement. That my angle QPR must be congruent to angle SPR. Why is that so? Well, that's because we have our angle bisector. Now it also tells me that it bisects angle QRS, meaning QRS over here on the right, it's also splitting this angle down the middle. And so I actually can add that into my step 2 as well. These angles are congruent. Angle QRP congruent to angle SRP. And I'm going to add that into step 2 because it's the same reason, because my angle bisector. Now that's pretty much all of my given information, but as I look at my diagram, I do see something that I can mark for certain. We have a shared side. And so if I mark that shared side, I need to come over here and make a statement in my proof. PR must be congruent to PR. That is the reflexive property. And now I do see that I have congruent triangles because I have proven one of my shortcuts, angle, side, angle. So I can go ahead and say that my triangle of PQR must be congruent to triangle PSR by the angle, side, angle shortcut. Now I'm not finished because what I'm actually trying to prove is that my segment PQ is the same length as my segment PS. But now I'm going to go ahead and say we can prove PQ must be congruent to PS because the corresponding parts of congruent triangles are congruent, or CPCTC. Let's take a look at another one. The proof at the bottom, this time I see I'm trying to prove congruent angles. I'm trying to prove that my angle XYW is congruent to angle ZYW. Let's go ahead and find those. Angle XYW would be up here, and ZYW would also be the other angle up at the top. I'm trying to prove that those two angles are congruent. Well, again, I'm going to use my same strategy because I see I have two smaller triangles. I'm going to see if I can prove those congruent first. And as I look here, we are going to start with our given information. This time, my given information tells me that YW bisects XZ. Also that XY is congruent to YZ. Well, let's go ahead and mark those congruent segments. XY is congruent to YZ. YW bisects XZ. This time, I have a segment bisector. My segment YW is bisecting segment XZ. Well, I know if it's bisecting that segment, it's cutting it equally. However, if I make those markings on my diagram, I need to come over here and make a statement about that in my proof. So I'm going to say that XW must be congruent to ZW. Why is that? Well, that is because of our bisector, which this time happens to be a segment bisector. And as I look, there are a couple different ways to prove these triangles congruent, but probably the easiest way is to now mark my shared side. My shared side would give me my shortcut of side, side, side. So YW congruent to YW by the reflexive property. And now I'm going to go ahead and say that my triangles are congruent. Triangle XYW congruent to triangle ZYW because we have shown side, side, side shortcut. Now that is not the only way to prove those triangles congruent. That's probably the most popular. Now that my triangles are congruent, I can go ahead and take a look at my angles at the top. I'm trying to prove that this little angle here would be congruent to this little angle here. And I'm going to say that that has to be true. Angle XYW is congruent to angle ZYW because, again, if I have congruent triangles, the corresponding parts of my congruent triangles must be congruent, or CPCTC. The other thing that I wanted to point out is you'll notice that step 4 and step 5 look very similar, yet they are different because of my symbol. One says I have congruent triangles, while the bottom one says I have congruent angles. So be mindful of which symbols you're writing. Flipping our paper over to the back side. In proof number 3, it looks like we are trying to prove that we have some congruent segments. Segment PQ congruent to segment LM. Again, I have two triangles, and so I'm going to start by trying to prove those triangles congruent. Now in this case, we have quite a bit of given information. As I read through it, angle PNQ congruent to angle LNM. Well, they do have those marked already, but I'd like to double check. Segment PN congruent to segment LN. And then they tell me that N is the midpoint of QM. So if N is the midpoint here, I know I can go ahead and say that QN must be the same as MN. But if I make those markings, I need to make that statement. Why do we know that that would be the case? Well, that is because of our midpoint. And now as I look at my diagram, I actually have some congruent triangles. We have shown our triangles congruent using side, angle, side shortcut. So my triangles are congruent, like SAS. Which then would allow me to say that my segment PQ here must be the same as my segment LM. And so in step number 4, PQ must be congruent to LM, once again by CPCTC. Corresponding parts of congruent triangles are congruent. Okay. Last one. Here, I'm trying to prove that my segment AB is congruent to my segment DB. We know that we're going to go ahead and start with our givens, and that our strategy is going to be to prove first that we have congruent triangles. Now, my given information tells me that AD is the perpendicular bisector of CE. Okay? If AD is bisecting CE, this is the segment that is being cut in half. And so I know that I can mark CB congruent to EB. And I'm going to go ahead and state that. Why do we know? Well, that's because of our perpendicular bisector. They tell me that CD is congruent to EA in my givens as well, and that is marked. Now in this diagram, I do see that I have some vertical angles, but my vertical angles would give me the SSA shortcut, which does not prove triangles congruent. However, we're going to go back to the fact that this is a perpendicular bisector. And so perpendicular allowing me to say, well, these must be 90-degree angles. And so in step number 3, I'm going to say that the measure of angle CBD must be 90 degrees, along with the measure of angle EBA must be 90 degrees. Why would that be? Well, again, that's going to be because of our definition of our perpendicular bisector. Now, with my 90-degree angles, I can go ahead and say that I have some right triangles. So my triangle CBD is a right triangle, and my triangle, say, EBA is also a right triangle. By the definition of the right triangle. Well, with my right triangle here, I see I have congruent hypotenuse and I have congruent leg. And so I have actually shown that my triangles are congruent. Triangle CBD must be congruent to triangle EBA. because we have shown the HL shortcut, or the hypotenuse leg. If I have congruent triangles, that would then allow me to say that my segment here, AB, must be the same length as my segment DB. AB must be congruent to segment DB by the CPCT shortcut. Corresponding parts of congruent triangles are congruent.